this problem, we have sine of arcsine of 3 over 5 plus arctangent of 2. We're going to find or evaluate without using a calculator. Inside of the parentheses, we have the inverse function as the first term as the inverse sine or the arcsine, and the second term as the arctangent or inverse tangent. Recall the inverse trig function returns the value as an angle. So this one is one angle, the other one is another angle. So we're gonna name the first one as an angle A, the second one as an angle B. So on the side notes, I'm gonna put on the side here, let A be arcsine of 3 over 5, which is the inverse sine of 3 over 5, which is telling us as the sine of A equals 3 over 5, or is opposite over hypotenuse from the three sides of the right triangle diagram. And this is a right triangle diagram for an angle A. When we locate an angle A, the opposite side going to be 3, the hypotenuse going to be 5. Therefore, the adjacent, which is from the use of the Pythagorean theorem, 5 squared minus 3 squared equals square root of 25 minus 9, or square root of 16, returns the value 4. The next inverse function is the arctangent of the two. So we're going to let an angle B equal arctangent 2, or the inverse tangent 2. That means the tangent of an angle B equals 2. The angle B with the trig function tangent, the tangent is formed by using the opposite divided by adjacent side of the right triangle diagram. We see the value 2, we can write it as 2 over 1 to see as a fraction. And then we're going to form the right triangle diagram again, locate an angle B. Opposite side is 2, adjacent is 1. Therefore, the hypotenuse is 1 squared plus 2 squared, or square root 5. We got two right triangle diagrams to use to complete the problem. Back to the main part of the problem. If we rewrite the inverse side of the 3 over 5 as A, inverse tangent of the 2 as a B, so the problem becomes sine of A plus B. That is the sum formula, the sum of the sine function. And the formula of the sum of sine function is sine A cosine B plus cosine A times sine B. That means we're going to look for the sine of A, cosine of A, and also cosine of B, cosine of B to replace into the expression here. The right triangle diagram that we formed earlier, for an angle A, we know the sine A because the problem gives it to you. And then for the tangent B, that's the given number. So the right triangle for an angle A, the sine of A is 3 over 5. The cosine of A, which is from adjacent over hypotenuse. Adjacent is 4. Hypotenuse is 5. We got the value for the cosine A. And for an angle B, we're going to need both sine and cosine. So the sine of the B, which is the opposite over hypotenuse, or 2 over square root 5. For the cosine of the B, which is formed by using the adjacent divided by hypotenuse. Adjacent is 1, hypotenuse square root 5. Then we get both sine and cosine of B to use into the sum formula of the sine function for the main part. Now, the sine A will be replaced with the value 3 over 5. The cosine B will be replaced with the value 1 over square root of the 5. And then the next term, the cosine A, clean up this right in the better form. Cosine A is 4 over 5. And the sine B is 2 over square root 5. And after that, we just simplify the numbers. The first product, we get 3 divided by 5 square root 5. The second product, we get 8 divided by 5 square root 5. Same denominator, we combine the numerator to be 11 over 5 square root 5. If you would like to do as a rational denominator, you can multiply both top and bottom by square root 5 and simplify the number as 11 times square root 5 divided by, sorry, this one. So 5 times 5, which is 11 square root 5 divided by 25 as another form of the solution.